Okay, good morning. Welcome to
FamilyMath number 287.
Okay, so this is a follow-up to the project we did yesterday, which was about two overlapping squares. And somebody named Ben, actually, on my blog, commented that he had seen that problem in something called the Julia Robinson Math Festival, and he sent...
Oh, it's 20 there?
Oh, I'm sorry. He sent a bunch of other problems. And two of them looked kind of fun, so I thought we'd give them a try. So the first problem we're going to take a look at here is we have two circles, one with radius 15 and one with radius 20. And they overlap a little bit at the points of intersection here. Sorry, they meet at right angles. And the question's kind of an interesting question. Find the difference in area between the non-overlapping portions of the circle.
Those.
Yeah, you want to... Sorry, I keep hitting the tripod. You want to shade those in?
Okay, so
There's one.
that's not.
Okay.
And then there's this portion.
Yeah, we're supposed to find the difference in area between those two portions.
Well,
I have an idea that we could try.
Okay.
So, I was thinking we could use the areas of the circles to find it out. Like if we write down, can I erase this?
Sure.
Alright. If we write down an equation, so the area of the smaller circle is 225 pi.
because the area formula is pi times the radius squared.
Very good.
And then I'm going to call this is the area here, this is x pi. Or actually, I'll just call it x.
Okay, yeah, you can just call it x. You don't have to call it x times pi.
So the area of this part is 225 pi minus x.
Okay, why is that? Why is that 225 pi minus x?
Well, because it's the area of the whole circle is 225 pi, and then this is the overlapping part.
Okay.
And it's same for the other one, except that the area is 400 pi minus x.
And why is that?
Because the radius is 20,
Okay.
so the area of the circle is 400 pi, and then you subtract out the x.
All right.
So the difference of the areas would be 400 minus x minus 225 pi minus x. And I think it's minus this quantity.
All right. Can you tell me, is that the right thing we're trying to find? Is that the difference between the non-overlapping areas?
Well, yeah.
Okay. And did it get the parentheses right?
Yeah.
Okay. Why did the parentheses go around the whole thing? 225 pi minus x.
Well, because you're minusing this away from this whole thing, and that whole thing.
Okay.
But then wouldn't there be parentheses around this part too?
Well, there could be, but it's
Yeah. Probably to be careful, and that would be a good idea,
Yeah.
actually.
All right.
So what does this
top
end
part.
up equaling?
So multiply the minus through. Oops, 400 pi minus x.
All right.
400 pi minus x. Hard to write sideways.
Yeah. Sorry.
And minus 225 pi plus x. So we have a minus x and a plus x.
But they can cancel.
Yep.
Ooh.
So that means we just have 400 pi minus 225 pi.
And what is that? See, can you evaluate that? 400
Well-
pi minus 225 pi?
Let's see. I think it's 175 pi.
Very good.
So 175 pi is the difference between the non-overlapping areas.
And what's the surprising thing about this solution to the problem?
It didn't involve this overlap.
It didn't matter what x was.
It didn't matter what x was. So that actually means that the circles don't even touch, so there's no overlap. The difference is the same. And if the circles completely overlap, the difference is the same.
Cool.
So you didn't see the square problem from yesterday, but the square problem was like that. It didn't matter how that square rotated.
Yeah.
the area of the overlap is always the same. This one, the difference between the overlaps is always the same. What do you think the trap part about this problem was? What would be a mistake?
Trying to find out what x is.
Yeah, trying to calculate that area.
That's
It's pretty
kind of
hard.
hard. Because, I mean, it could be, like you said, that it's maybe not even touching or maybe all the way in.
Yeah.
You could slide this really anywhere along a line like that.
Yeah, trying to find that area. And see, they gave you some dimensions and they gave you this right angle and everything, so they were trying to really trick you into trying to calculate that area, but it turns out you don't have to at all.
Yeah.
Pretty cool, right?
Yeah.
All right, next problem.